most common task you'll probably perform in your Angular apps: consuming a REST service. Most modern client applications require data, and REST services are the most popular way of delivering that data. Don't worry if you're unfamiliar with what makes a service a REST service. I'll quickly cover that in the next clip. After that, I'll show you how to consume a REST service using Angular's HTTP client and observables. Along the way, we'll take a brief detour and I'll show you a couple of powerful techniques for manipulating data using RxJS operators. There are lots of demos and lots of code to write, so let's get started. Service is to provide some context for the code and techniques you'll see in the remainder of this module. The term REST is really an acronym. It's short for Representational State Transfer. The general idea is that you'll be transferring resources, which are just objects, to and from the server and taking advantage of the inherent features of the HTTP protocol to specify what should be done with those resources. You may often hear REST services referred to as a Web API or an HTTP API. This is because they're so often used as the service architecture for web services that operate over the HTTP protocol. REST services take advantage of different HTTP verbs to specify CRUD operations that should be performed on the server. CRUD is just another acronym that stands for Create, Read, Update, and Delete, the most fundamental ways to manipulate data. REST services work with resources, and there are conventions applied to URLs to allow you to address individual resources as well as collections of resources. I'll show you how to do both in upcoming demos. REST services also make use of HTTP response codes to indicate the success or failure of the requested action on the server. You're probably already familiar with the HTTP 200 response, letting you know everything worked as expected. REST services report success with a little more granularity by using additional codes in the 200 range. As I mentioned a moment ago, CRUD is an acronym that describes the most fundamental ways to manipulate data, and they're what I'm going to focus on in this module. So I want to show you how those operations map to the HTTP features in a RESTful service. The C in CRUD stands for Create. When you want to create a new resource on the server, which usually means inserting a row in a database, you send the request to the server using the HTTP POST verb. Angular makes this easy by including a helper method on the HTTP client named POST. Similar helper methods exist for the other HTTP verbs we'll use. The URL should represent the collection to which you'll add the resource. In this example, the URL is API/books, so we know we'll be inserting a new book. The new resource should be passed to the server in the body of the HTTP request. By convention, if that operation is successful, the server will return the HTTP status code 201 created, and the newly created resource will be returned in the body of the HTTP response. The R in CRUD stands for read, and you read data from a REST service by using the get HTTP verb. You can get an entire collection of data by just addressing the collection in the URL like the first example here. API/books. You retrieve an individual resource by adding another URL segment that contains the ID of the resource. The second URL here will retrieve the book with ID 5. Successful GET requests should return the HTTP 200 status code we're all familiar with. The U in CRUD stands for update. You update data by submitting a request with the put HTTP verb. The URL should address the specific resource being updated, and the body of the request should contain the resource itself, usually in JSON format. If the update is successful, the server should return the HTTP status code 204 no content. In order to delete data, you submit an HTTP request with the delete verb and use the URL to address the specific resource you want to delete. If the deletion is successful, the server should return 204 no content, just like the update operation. Okay, there's more to REST services than what I've covered on the last couple of slides, but these are the most commonly implemented features and the ones most critical to supporting basic data operation. Let's now see the role observables play when using Angular's HTTP client to interact with REST services. Methods that exist on Angular's HTTP client class that you'll most often use to interact with REST services all return observables. So before we get into the demos, let's take a quick look at how to work with those observables. Observables are really the most fundamental construct in RxJS, and they represent a set of values that can be delivered over time. In the case of HTTP requests, that value is usually just the HTTP response. In this code, I've defined a method named getAllBooks. It contains one line of code that calls the get The get method creates an HTTP request with the get HTTP verb. The URL it will request is /API/books, which will return an array of books in JSON format. That JSON will automatically be deserialized into an array of book objects as specified by the generic parameter I'm passing to the get method. The get method returns an observable that wraps up the data returned from the server. We also use a generic parameter to specify the type of data wrapped in the returned observable, which, in this case, is the same type of data returned from the server. I can call this function in some other part of the app, just like I would call any other function, but because it returns an observable, I need to handle the response a little differently. In order to actually receive the results from an observable, you must subscribe to the observable. That's done by calling a method named subscribe. Rather than storing the returned observable in a variable and calling methods on the variable, it's common to just chain calls onto the function that returns the observable. The results from the observable are handled by callback functions passed to the subscribe function. It takes three optional functions as parameters. The first is the function that will contain data if the call executed successfully. I'm using an arrow function here. The function takes one parameter, which I've named data. Notice that the type of that parameter is an array of books. This matches the type of the generic parameter added to the observable returned from the getAllBooks method. The body of the arrow function just assigns the data to the allBooks property on the component. The second callback function you can pass to subscribe handles errors. It's passed one parameter, which is the error, and here I'm just logging it. We'll spend a lot more time on error handling in the next module. The third callback function will execute when the observable is done providing all of the data it's going to provide. This is basically a completion handler. It takes no parameters and is a good place for you to do any work you want to do once you know the observable is done. Okay, now that you know what REST services are and the basics of working with the observables returned from Angular's HTTP client, let's get into some demos. In this demo, I'm going to show you how to retrieve a collection of resources from a RESTful web service using Angular's HTTP client. I'm going to start by opening the data service, which is located in the core folder. The service already has many of the methods needed to return data to the components in the app, but they all just return data that I've hard-coded in the client. It's not currently retrieving any data from the web. The getAllBooks method just returns the AllBooks array, which contains the hard-coded data I imported at the top of this file. That and change the method to get the data from the server instead. Remember that in the last module I configured the data service to use Angular's HTTP client class. It's being injected into the constructor and assigned to a property named HTTP. I can refer to it by typing this.http. I'll add another dot and the code completion help shows me a list of the methods I can call in the class. Notice that many of them match the names of HTTP verbs. Calling these methods will create a request that uses that verb. You can see here all of the methods that map to the CRUD methods I talked about earlier: get, post, put, and delete. Because this method will retrieve all of the books on the server, I'll call the get method. The data returned in the body of the HTTP response will be an array of book objects, so I'll specify a book array as the generic parameter for the get method. The only parameter I'm going to pass to the method right now is the URL for the books collection on the server. The Node web server I've included with the demo project contains a collection of books at the address API/books. You can see that I've got one of the dreaded red squigglies on the function return type. But before I fix that, I want to peek at the definition of the get function itself. I'll put my cursor inside it and then press Alt F12 inside Visual Studio Code. That opens up a little quick peek window that shows me the type declaration file containing the definition of the get method. There are a couple of things here I want to point out to you. Notice the comment above the function definition. Construct a GET request which interprets the body as JSON and returns it. The GET method expects the data to come back from the server in JSON format and will automatically map it into the array of books I specified as the type parameter on the method. Speaking of that type parameter, you can see it represented here on the function definition with the letter T. I'll scroll down just a little bit and you can see that the return type for the GET method is an observable of T. So whatever type I pass as the type parameter to the method will be the type that gets wrapped up in the observable that's returned from the method. In the case of my getAllBooks method, that will be an array of books. Okay, we now know the get method itself returns an observable, and I just want to pass that observable onto the component that called this method on the data service, so I'll just add the return keyword in front of this line of code. That gives me an even bigger red squiggly. I'll hover over it and it tells me that type observable of book array is not assignable to type book array. I just need to update the method to specify that it will now return an observable of book array. Just so that we can see when the function executes, I'm going to add a console.log statement at the beginning of it. This getAllBooks method is currently called from the dashboard component, so I'll now open it. I'll scroll down to the ngOnInit method and you can see I now have an error in this code because I changed the return type of getAllBooks. It was returning an actual array of books which I was assigning to the AllBooks property, but that won't work anymore. I'll remove that assignment but leave the call to the function on the data service. I now don't have any errors, so let's start up the app and give it a try. I'll open the terminal in Visual Studio Code and type the command npm start. Once the server is up and running, I'll close the terminal and jump over to my browser. I'll load the app by going to localhost:3000. Okay, the app loads, but we very conspicuously don't have any books displayed. I'll open the developer tools, go to the console tab, and refresh the app. You can see the log message I added to the getAllBooks method on the data service, so we know it's executing. I'll now go over to the network tab. The app has obviously made several requests to the server for the JavaScript files, but we don't see a request to /API/books. The reason we don't see an HTTP request, even though we know the method executed, is because I never subscribed to the observable returned from the data service. If there are no subscribers, the observable doesn't bother making the request. It's kind of like that old philosophical question. If a tree falls in the forest and there's no one there to hear it, does it make a sound? Maybe. In this case, if an observable is returned to a component and there's no one there to subscribe to it, does it send the request to the server? No, it doesn't. No philosophical debate required. So let's now go back to the code and subscribe to that observable. The getAllBooks method returns an observable, and observables have a method named subscribe, so I'll just chain a call to that method onto the returned observable. Remember from the slides that the subscribe method takes 3 callback functions as parameters. I'm going to pass them in as arrow functions. You can quickly check its signature using the trick I showed you earlier. Put your cursor inside the function name and press Alt F12 in Visual Studio Code. I'll be using this third overload, which takes what is effectively a success handler, an error handler, and a completion handler. The first function will be passed the data returned from the server as a parameter. It will be the array of books, and I'll just assign it to the AllBooks property I was using before. That's the property the view binds to. The second function is passed any error that occurs. I'm just going to log it for now. I don't often have a need to use the completion handler, but I'll add one now that just logs a simple message to the console. Okay, now that I've subscribed to the observable, let's go back to the browser and see if the HTTP request actually goes to the server this time. I'll refresh the app and we do now get books on the dashboard. You can also see the request for the books collection at the bottom of the Network tab in the Developer Tools. I'll click on it and we can see the URL that was requested and that it was successful and returned a 200 OK status. On the Preview tab, we can see a preview of the data sent back in the body of the response. In the next demo, we'll continue to add calls to the server for data, and I'll show you how to request just a single book from the REST service. In this demo, I'm going to update the demo app to request a single book from the REST service using the book ID. I'm here in the data service again, and this time I'm going to update the getBookById method here at the bottom of the file. It currently takes the hard-coded array of books I imported at the top of the file and uses the find method to return the book containing the ID passed to the method. I'm going to remove that code and have it make a call to the REST service instead. This is going to look very similar to the code in the getAllBooks code above. I'm again going to call the get method on the HTTP client, but this time the generic parameter I pass to it will just be book instead of an array of books. I'm going to use a template string to specify the URL for the request. The request will still go to the books collection on the server, but I'll append the ID passed to the method as the last segment of the URL. We learned in the last demo that the get method returns an observable, and I'm just returning that observable from my method, so I need to update the return type to an observable of type book. This code is called from the edit book component, so I'll now open it up. You can see that I've got an error in the ngOnInit method because the return type of getBookById changed. I'll remove that assignment and then subscribe to the observable return from the method just like I did in the last demo. The assignment to the selected book property that I just deleted is effectively being moved to the first callback function passed to the subscribe method. If the call was successful, the book will be passed to this callback as a parameter, and I'll then assign it to the selected book property on the component. The second callback handles errors. I'll again just log it to the console. We'll add some more elaborate error handling in the next module. Remember that the third parameter to the subscribe function is a completion handler. It doesn't take any parameters. All of these are optional, and I find that I rarely have a need for a completion handler, so I think I'll just leave it off this time. Okay, I've changed the data service to make a call to the REST service for a single book, and I've updated the edit book component to subscribe to the returned observable. Let's now hop over to my browser and test it out. I'll refresh the app, and it looks like the dashboard still loads fine. Notice as I hover over the edit links for the books, the URL associated with each link. The app will route to the edit book component and treat the last segment of the URL as a parameter that is the ID of the book. The component captures that ID and then passes it as the parameter to the getBookById method on the data server. I'll click the edit link beside Winnie the Pooh, which has an ID of 2. At the bottom of the Network tab in the Developer Tools, we can see the request it made to the REST service. The URL was /API/books/2. I'll click on it and we can see the data that was returned in the body of the HTTP response, as well as the successful HTTP status code. Just to quickly demonstrate the error handler I passed as the second parameter to the subscribe method, I'll change the URL to look for book ID 300, which doesn't really exist. You can see in the Network tab at the bottom that the request returned status code 404. I'll go back to the browser console, and you can also see that the error was logged there by the callback function I passed to subscribe. Okay, let's now go back to the code and tweak it slightly to pass some specific HTTP headers to the server. The service I wrote is only coded to return JSON data, but it's common for services to have the ability to return data in multiple formats. In those cases, it's up to the client to pass an HTTP header to tell the service what data format it would like to receive. HTTP headers are also used to pass other useful bits of data to the server, so it's important to understand how to configure them when using Angular's HTTP client. I'll go back to the data service and we'll add some more code to the getBookById method. I'll declare a new variable named getHeaders because it will store the headers I want to add to this GET request. Its type will be HTTP headers, and I'll initialize it to a new instance of that class. Visual Studio Code doesn't seem to recognize the type, but that's just because I haven't imported it into this file yet. I'll put my cursor over the error and then use this little quick fix light bulb to add HTTP headers to the existing import declaration from Angular Common HTTP. The error then goes away, and if I quickly scroll back up to the top of the file, you can see that HTTP headers is now being imported from the same module as Angular's HTTP client. Okay, there are several ways I can specify the headers I want to use, but I think the easiest to implement and read is to just pass an object literal to the HTTP headers constructor. I'll add a pair of curly braces, and then I can just include the headers I want as properties on this object literal. I want to tell the server that I want JSON data returned, so I'll add an accept header and give it the value application/JSON. If I want to add additional headers, I can just add a comma and then include as many more as I want. I don't have any security on my service, but just for demonstration purposes, I'll add an authorization header and set its value to my token. This will create and store these headers in the getHeaders variable. I now need to add them to the actual HTTP request. The get method I'm calling on the HTTP client can also accept a second parameter containing options you want to apply to the request. It's an object literal, so I'll add a comma after the URL parameter and then a pair of curly braces. There are several properties you can specify on this object. To set the headers, you simply use the headers property. I'll assign it the variable I declared above containing the accept and authorization headers. Let's now go back to the browser and see if the new headers are being included with the request. I'll refresh again and go over to the Network tab in the Developer Tools. I'll click the Edit link beside one of the books and then click on the request that generated on the Network tab. I'll scroll down just a little bit to the Request Headers section, and you can see that the request was sent to the server with an accept header requesting JSON data and an authorization header set to my token. The code I wrote to do this obviously works fine, but I made it a little more verbose than necessary for the sake of clarity. Rather than assigning headers to a variable and then using that variable to attach the headers to the request, you could just create and assign the headers right on the request. I'll just copy this code and paste it over the variable I used on the options object. I can now get rid of the variable above. I think I like this form a little better, but feel free to use whichever style you prefer. We're now successfully retrieving a collection of books and single books from the REST service. In the next couple of clips, we'll take a slight detour and see how we can use RxJS operators to transform the data being returned from the server. I want to take just a few minutes and talk about how you might take advantage of RxJS operators when working with the observables returned from your HTTP request. I'm not going to go into great detail in this course, but I do think it's important that you're at least aware of some of the capabilities they offer. Operators are really just bits of code that operate on observables and return an observable. Because they return observables, you can chain multiple operators together to perform complex transformations on your data before returning it to your components. This is really the power of operators as they relate to HTTP requests specifically. They give you the flexibility to transform your data into exactly the shape you need it, which can be very helpful when working with third-party services that may not return data in exactly the format you would prefer. In this demo, I'll show you a simple example of using RxJS operators to transform data before returning it to the calling component. Let's imagine in this demo that the service where we're getting the books is actually a third-party service and we really can't control the shape of the data being returned. However, we want to work with the data in our app in a slightly different form than what we're getting from the service. The first thing I'm going to add is a new class to the models folder in the project. I'll name it oldbook.ts. Inside it, I'll export a new class named oldbook that will be very similar to the book class we've been using. I'll give this class a book title property and a year property. We're going to pretend in this demo that this is the format we would prefer to use for our book data. I'll now open up the data service again and write some code to request a book from the server, but transform it into an old book instance before returning it to the component. I first need to import the old book class I just created. I'm going to use a couple of RxJS operators to transform the object returned from the server, so I need to import them as well. I'll start with just the map and tap operators. I'll then come down to the end of the file and write a new method named getOldBookById that will be similar to the getBookById method just above it. Rather than returning an observable that wraps up a book, this method will return an observable that wraps up an old book. The request to the server will be the same. It only has books, so I'll copy the call to the get method from the getBookById method above and paste it into this new method. I'll leave off the headers for now. The get method will return an observable and I can apply operators to observables. I'm going to use the pipeable operator syntax released with version 5.5 of RxJS. You may also see these referred to as lettable operators. I just chain on a call to the pipe method and then I can pass to it a comma-separated list of operators I want to apply to the object returned from the server. One of the most useful operators in RxJS is the map operator. You pass it a function that will accept the type currently wrapped in the observable and return the data transformed in some way. I'm going to use an arrow function. The parameter b here will be the book instance returned from the server. I'm going to map its data into an old book instance. The book title property on the old book will be assigned the title property from the book returned from the server, and the year property will get the value of the publication year property on the book. I'll add one more operator just for demonstration purposes. The tap operator doesn't transform the data, but just gives you a way to execute some bit of code before the final observable is returned. Because the map operator returns an observable that wraps up an old book, the function passed to the tap operator will receive that old book as a parameter. I'll name that parameter classic book. I'll just log it to the console. Just to further make the point that all of our return values match, I'll hover over the call to map, and you can see that it returns an observable. It wraps to the next line, but it's an observable of old book. I'll also hover over the call to tap, and you can see that it also returns an observable of old book, which matches the return type I gave the getOldBookById method. In order to test it, I need to actually call getOldBookById. I'll do that in the edit book component. I'll add an import statement to import the old book class. I'll then add some code to the end of the ngOnInit method. I'll call the getOldBookById method on the data service and subscribe to the observable it returns. The success handler will receive an old book instance as a parameter. I'll have it log the title of the book with a template string. I'm not going to bother with the other callback functions I can pass to subscribe right now. We're now ready to test it out. I'll go back to the browser and refresh the app. I'll click the edit link beside one of the books. The correct book is loaded on the page, but we can also see the message in the console that logged the title of the book after it was transformed to an old book instance using the RxJS operators. This isn't a course on RxJS, but I just wanted to give you a taste of the power operators offer when you need to transform and manipulate the data in your observables. Okay, in the next demo, I'll show you how to create, update, and delete data with the REST service. In this demo, I'm going to add the remaining CRUD operations for books that will allow us to create, update, and delete them. The first thing I want to do is add the code to the data server to insert, update, and delete books. I'll add a separate method at the bottom of the file for each operation. I'll name the first one addBook, and it will take a book object as a parameter. The return type is going to be an observable of book. I'm going to add the book by making an HTTP request with the post verb. I can do that by using the post method available on the HTTP client. By convention, when a resource is added to a REST service with a post request, the newly added resource is returned in the body of the HTTP response. That object will also be the object that gets wrapped into the observable returned by Angular's HTTP client. Therefore, I'm going to specify the type of that object, book, as the generic parameter on the method. I'm also returning from this method the same observable returned by the post method, which is why the return type of addBook is an observable of book. Just like the get method we've already seen, the first parameter to post is the URL where the request will be sent. I'm adding a book, so the URL is the same address I used when retrieving all books, /API/books. The server will interpret the two requests differently because of the different HTTP verbs being used. The second parameter I'll pass is the book object to be added, which is the new book parameter passed into this method. The third parameter is an options object. I'm again going to use the headers property of it to add a header to the request. I'll set the content type header to application/JSON to let the server know that the content in the body of the request contains JSON data. The code to update a book is very similar to this, so I'll just copy this entire method and use it as a starting point. I'll name this one update book, and I'll rename the parameter updated book. Updates to a resource are made by sending a request to the service with the put verb. So I'll use the put method on the HTTP client, which will make sure that verb is used. By convention, nothing is returned in the body of the HTTP response when a resource is successfully updated. Therefore, I'm going to change the generic type parameter from book to void. I'll need to make the same update to the return type for the method. The URL is slightly different for updates. It should include the ID of the resource to be updated as the last URL segment, so I'll change this to a template string and pass in the book ID of the book being updated. The book I'm passing to the server is the one in the updated book parameter. I'll leave the same header on the put request. I'll now write a method to delete a book. It's much simpler. I'll name it delete book, and it will just take as a parameter the ID of the book to be deleted. It will also not return anything in the body of the HTTP response, so I'll set the return type of this method to be an observable void, just like the update book method above. To delete a resource, you submit a request using the HTTP delete verb, which, as you might expect, I can do with another handy helper method on the HTTP client. I'll pass void as the type parameter. The URL will be the books collection we've been using on the server, with the ID of the book to be deleted passed as the last URL segment. I don't need any special headers on this request. Okay, I've now got methods on the data service for add, update, and delete. I now need to update the components that will call these methods. I'll go to the add book component first. I'm not currently using the data service in this component, so the first thing I need to do is import it at the top of the file. I'll then inject it into the constructor and store it in a private property named data service. A little further down in the file, you can see that I've already got a method on the component named saveBook. It gets called when a user clicks the Save button on the Add Book screen. The form values are passed into the method and then cast to a book instance. I know it's a new book, so I then set its ID to 0. The server will give it a real ID as part of the save process. I then just log a warning that this method isn't fully implemented yet. I'll delete that, and then I can make my call to the data service. I'll call the add book method I wrote a minute ago and pass in the new book. We know that this method will return an observable, so I now need to subscribe to it. I'll call the subscribe method and then write the function that will execute if the book is added successfully. Remember that I mentioned the newly added book will be returned in the HTTP response. That book will be passed to this callback function as a parameter. I'll just log it to the console. This will give us a chance to see how it may differ from the book object that was passed up in the request. I'm logging the book that was sent in the request here, and I'm logging the book that came back in the response here. If there's an error, I'll just log it to the console. I'm not going to add a completion handler right now. That's all I need to do to the add book component. Let's now move on to the edit book component. I'll close the sidebar to give myself a little more room in this file. This component already has the data service injected into it, and I've already got a save changes method that gets called when a user clicks the save button on the update screen. I'll delete this warning and use a code snippet to paste in the code to call the data service. This code is very similar to the code I just added to the add book component. The current book is passed to the update book method on the data server. Remember that no book is returned in the HTTP response, so I just log a message using the title I already have. I'll also just log any error I get, just as I've done before. That's it for editing books. Deleting books is handled on the dashboard component. there's a delete link beside each book on the dashboard that will call this delete book method on the component, passing in the ID of the book to be deleted. I'll get rid of this warning that the feature isn't implemented yet. I'll then use another code snippet to paste in the new body of the function so you don't have to watch me type so much. This should be looking pretty familiar by now. I call the delete book method I wrote on the data service, passing it the ID of the book to be deleted. I then subscribe to the returned observable. The first method passed to the subscribe method will not be passed any data because nothing is returned in the body of the HTTP response for a delete operation. However, I am doing just a bit of work in this function to remove the deleted book from the list of all books on the dashboard. I use the findIndex method that exists on the array of all books to find the index of the book with the ID of the one that was deleted. Once I have that index, I call the splice method on the array to remove the item at that index. The dashboard view that displays the contents of the all books array will automatically be updated to reflect the removal of the book. Below this, I'm again just logging any error that occurred. Okay, time to test out all of these changes. I'll refresh the app and then click the Add Book link at the top of the page. I'll add the book Corduroy by Don Freeman. I'll set the publication year to 2000, even though I know that's not correct. I'll fix it in just a minute. Before I click the Save button, I'll clear the request on the Network tab in the Developer Tools just to make things a little easier to read. I'll click the Save button, and we see the new HTTP request immediately appear down below. I'll click on it so we can see the details. We can see that the request was submitted to the books collection and that the post verb was used. Just below that is the HTTP response code. I mentioned on one of the slides earlier in the module that a successful post request should return 201 created, which is what we see here. Remember that in the Add Book component, I logged the book just before the HTTP request, as well as the book that came back in the HTTP response. Over here in the console, we can see the result of those log statements. Notice that the only difference in the objects is the value of the book ID. It was submitted to the server with an ID of 0, but the server assigned the book an ID when it was saved, and the book returned in the response has that ID of 7 on it. The ability to capture the new ID from the response is one of the reasons it's customary to return the newly saved item after it's saved. Let's now test an update. I'll click the book tracker link at the top of the page to take me back to the dashboard. You can see here that Corduroy has been added to the list of all books. I'll click the edit link beside it to fix that incorrect publication date. Corduroy was actually published in 1968. Before saving that change, I'll go back to the Network tab in the Developer Tools and again clear the list of requests. I'll click the Save button and we see the new request appear below. You can see here the URL where it was sent. It used the HTTP put verb as expected, and because it was successful, it returned the HTTP 204 no content response. That basically means that it was successful, but no data was returned in the body of the response. I'll hop over to the Console tab and scroll down a bit, and you can see the log message that Corduroy was updated successfully. Let's now test the delete. I'll go back to the Network tab and clear all of the entries first. I'll then click the Delete link beside Corduroy on the dashboard. The HTTP request shows up below in the Developer Tools. We can again see that it went to the correct URL, used the delete verb, and because it was successful, returned 204 no content. Also notice that the book was removed from the list of all books on the dashboard. Remember that I did that in the success handler when I subscribed to the observable returned from the HTTP delete request. Okay, everything is working fine. The app has now been updated to create, read, update, and delete book data using a REST web service. The service included with the demo app also supports all of the same operations for readers, so I would encourage you to practice these techniques by downloading the demo code and updating it to pass readers to and from the service as well. If you weren't already familiar with them, you should now have a pretty good understanding of how REST services work and, more importantly, how to communicate with them using Angular's HTTP client class. The combination of helpful shortcut methods, consistent use of observables, and the rich set of operators offered by RxJS make the HTTP client an ideal consumer of just about any RESTful service. In the next module, we're going to build on the code in this module and learn more advanced techniques for handling errors and retrieving data during route transitions with resolvers.